study single precision IEEE and double precision IEEE representation. I actually took live yesterday, but thanks to the lovely YouTube, it ate up some parts of my live stream. I guess it's some glitch. I don't know how YouTube has glitch, but yeah, whatever. So I covered that in shorts. I know the quality must have reduced significantly, but what else can I do? So yeah, let's get into this first. So when you do IEEE format, there are 3 to 4 things. Okay, you have to remember. So yeah, so first is single precision. Okay, single precision. For single precision, you have 32 bits. Okay, 32 bits total memory. Okay, total memory assigned is 32 bits. Then there comes, if you multiply it by 2, then you get double precision. And what do I mean by multiplying? You would understand that. So this is double precision. And when I'm talking about double precision, so it is 32 multiplied by 2, it is 64 bits. So you get double the storage. Okay. So now what happens is, there are sign bits, and sign bits is always one, either it is single precision or double precision, because it is always gonna be 0 and 1. It doesn't need much bits. 0 means positive. Wait a second, market died just now, so yeah, wait a second. So obviously we have 0 for positive numbers and we have 1 for negative numbers. Okay, so that's how we get it. So sign has 1 bits. Now you have to just remember like exponents, because this is less and you only need to remember this. Exponent is 8. Oh sorry, wait a second. This is exponent bits are 8 bits. Like these are bits assigned to specific purpose. Like there is a sign bit which tells if the number is positive or negative. So there is only two possibilities. Either it can be positive, either it can be negative. So only two numbers are needed to indicate that 0 and 1. So we only need 2 bits. We don't have to put much efforts. So there is exponent here. Now what we do is, this is 8. Okay, this is 8, and here we have our, wait a second, this is 11, which is plus 3. Okay, and how do you remember like how many mantis are there? Mantissa are the real thing. Okay, and exponent is the how many points you can skip, right? Okay, let me just write it. So yeah, I told you this is positive, negative, and this is like 2 raised to n, like 2 raised to how many numbers, like how many decimal points are there. Okay, and this is the real number. Okay, so how many bits are assigned to it? So you just have to add this 8 and 1, total minus s plus e. So you just have to remember like that, total minus s plus e, which is actually 32 minus 8 plus 1, which is actually 23. And also you can remember it in another trick, and here it is same thing as here, 52. So you can remember it in another trick, that you are 23, you do plus 3 here. Okay, now what you do, 23 plus 3, you did it. Now you have to multiply by 2, like this stuff, like double precision stuff, so you have to remember it like that, because 23 plus 3 is 26, and 26 multiplied by 2 is 52. So that's what pattern I could found. So you can remember it like that. Also there is bias. Don't be biased. So yeah, for 32 bits it is 128. Okay, 127. Sorry, because numbers are counted from 0 to 127. So it makes it 128 numbers. Now this is 1023 for 64 bits. And how this come, I will tell you. So what is 16 square? As most of you know, it is 256. So we take middle out of it, which is 128. Since numbers are from 0 to 127 in computers, so those are 128 combinations of numbers. So that's why 2 raised to, also this is 2 raised to 8. 2 raised to 7, sorry, not 2 raised to 8, 2 raised to 7. Also, 32 square, as you know, is 1024. So this is 0 to 1023, so it is 1024. And this is 2 raised to 10. So as you remember, this is 32 bits. So 32 divided by 2 is actually 16, right? Yeah, so 16 square is 128 or 127, which you have. And this double precision has divided by 2 is 64 divided by 2 is 32. 32 square is 1024. Simple stuff. Now what I would tell you is, how to find how to find decimal from single IEEE. Let's say it's not single or double. That doesn't mean like that. IEEE to decimal. Okay, how to convert that? IEEE to decimal. So what happens here is you have to write it like this. Okay, first is 1 minus 1 raised to s. Okay, minus 1 raised to s. Wait a second. Yeah, multiplied by 1 point m multiplied by 2 raised to e minus by s. And why do I say that? I will tell you later on after I explain you decimal to binary steps, decimal to IEEE steps. Okay, because it is just reverse of this. Okay, decimal to IEEE, how to do that? First, you have to convert decimal to binary. Also, you have to convert, this would be in binary, so you have to convert it in decimal. Decimal to binary, how to convert that? Integer divide by 2 and record reminders, reminders, I would write it as rem. Okay. Oh, Subaru, Natsuki Subaru, rem, ram, ha ha ha. You know ReZero anime? Yeah. So there was Rem. So yeah, Rem and Ram were two sisters, demon sisters, I guess, in that anime. So yeah, Rem came up. So integer divide by 2 and record reminders till getting 1, like smaller than 2, getting 1 or 0. Okay, and like any binary digit. And for fraction, what you do is fraction. Like you have to do the opposite. Fraction is a division number. Integer is a multiple of number. So you just have to do reverse. If it is integer, multiple of number, divide it. If it is fraction, if it is a division of parts of a number, then multiply it. Simple stuff, okay? You just have to do the opposite. So fraction, multiply by 2, and record integer part of it, till, wait a second, till you get a whole number, and here you go, and you converted decimal to binary. Now after that, what I would do is, yeah, So I also have to tell you what is bias. Wait a minute. So I have to tell you what is bias. For that, what I would do is, so bias is actually, yeah, I showed you here actually. Bias is the middle part of the number. Like 256 is the total combinations of number you can have, but so 128 is the middle number, so that's what it's bias. Like it shows you how far your number is or exponent is from middle. Okay, so that's how it what it does. Yeah, so here we go. So that's what bias does. So what I would do is then after converting that, second step would be you would get a binary number, right? Uh, then you would get some decimal, like there would be some binary point, like point would be there. So shift binary fraction point okay, binary fraction point to left and marker died. Right, number of shifts shift wait a second, shift binary fraction point to left, wait a second, till wait a second, till 1 point format, like 1 point something would be there, okay, 1 point format. Then I shifted the fraction parts, then write number of shifts as number of shift as 2 raised to n, okay, multiplied by 2 raised to n. Like let's say 128, I can write it as 0.128 multiplied by 10 raised to 3, because if I break this 10 raised to 3, I would just jump decimal to the right and I would get 128. That's how it works. Because what 10 it is decimal number, so there are one value place has 10 power because there are 10 combinations I can put in this. After I exceed that on that, then only I can shift to the next place. So that's why we multiply by 2 raised to 10 raised to n here, but here we have to multiply 2 raised to n because this is binary number. There are only two combinations in one place, and after that we shift here. So if we shift here, if I shift here, then I'm going 2 raised to something part. So that we are just indicating here, okay, so that numbers don't change, okay, question doesn't change. Right number of shift as 2 raised to n, okay. uh, so ignore 1 in one point M, and M is your mantissa, is your marker died. So M is your mantissa, okay? Sounds like mantis, praying mantis. Oh my god. So ignore 1 in 1 point M, and M is your mantissa. Then you have is 2 raised to N in 2 raised to N plus bias is your exponent, okay? Wait a second, I raised this part, sorry. Is your exponent. So 2 in 2 raised to N plus bias is your exponent. Convert it into binary, okay? Make it binary. Then what we have here is we have done bias and all of that stuff. So if negative number MSB equal to 1, if positive number MSB equal to 0, okay, and MSB is your left digit and most powerful, okay? So MSB is your most powerful number, okay? So that's why I told you in decimal 2, if I let's say it is 0, so it will be plus 1, and if it is anything raised to 0 is 1, and if it is 1, then it is minus 1. So you get the negative sign. And 1 point M, your mantissa is there. So 1 point, you just convert it into decimal fraction and you get the same thing. So your decimal number, and into 2 raised to here it was E minus bias, and if you add that like E plus bias it was, and if you reduce that bias, then you get E. So you can shift that mantissa and you get your real number, then you convert it into decimal and you get the thing. So that's how it was. Thanks for watching. Like, subscribe, see you next time. Bye. Yo, that was crazy. So maybe I would do it, but I might solve the question, but the only problem would be I won't be able to explain when I solve it, okay? Okay. Yo, what's up? Okay, this is your stuff. By the way, this is your formula, okay? So what we do here is, so here we go. So I hope you take screenshot and notes. Did you take it? I don't know. So I guess you have taken screenshot and notes. So now I'm gonna erase it, okay? Erase it completely. I'm gonna erase it completely. I don't know why yesterday's stream was cut short, because there was internet connection the whole time, and I even took the live, and camera quality was okay, and nothing was turned off or something. But I don't know what happened to YouTube. It just got cut short. Then now we in question we have 4.5. Okay. Oh my god, my marker is dead, bro. That's the problem. That's the exact problem we have here. So what we have here is 4.5. Okay. We have to separate 4 and 5. So what I have to do here is, by the way, this would be 0.5 because this is decimal number. So what I would do to 4 is 4 divided by 2. 2 2s are 4. Then the remainder is 0, and 2 ones are, oh, sorry, 2 ones are 2. Wait a second. 0, and also you have to fill till 8 bits. Yeah, I forgot. In IEEE, decimal to IEEE, fill mantissa, okay, mantissa, and exponent with zeros till 8, and 8 and you know, sorry, 23 and 8 respectively. So the steps are same for single and double precision. The only difference would come, wait a second, the only difference would come for single and double precision, stuff, by the table. Like I told you, mantissa would change, exponent would change, and bias would change. Okay, so here we are. So what I would have here is, so why do we do that? Because 2 raised to n spaces are there, because one space can handle 0 and 1, two possibilities. So 2 raised to n, how many spaces are there, that much possibility is there. Okay, so what we are doing here is 2, oh sorry, wait a second, 2 4 2 2s are 4, remainder 0, 2 2s are, wait a second, 2 1s are 2, remainder 0, 2 zeros are 0, 1 remainder. Now what do I do here is, I take 1 0 0. No, 1 0 0 is wrong, bro. 0 0 1, I guess, because not exactly. Am I doing something wrong? Oh, yeah. Wait a second. Yeah, 1 0 0 it is. Yeah, we go like this. So it would be 1 0 0. 4 is 1 0 0, as you know, because this is 2 raised to 0 place, and this is 2 raised to 1 place. This is 2 raised to 2 place, and we add them, and 2 raised to 2 is actually 4. So here we win this, and now I have to do for 0.5. 0.5 into 2 equal to 1. So I just have one decimal digit, 1 here. So here we are. So I have to do nothing right now. Wow. So I guess that's it, isn't it? Is it like that or something else? So I have 100.1. So I basically have 100.1. Wait a second. So when I I separated these fraction and integer parts. So I would even write that them separate. So this is 100.1. Our decimal and binary. Decimal converted to binary, fraction and integer. So now what I have to do is, I just have to note when I go, my decimal point goes behind 1, like after 1. So how many places did I go? 1 and 2. So I would write into 2 raised to 2. Understood? Now what I would do is, so this is our mantissa, by the way. So mantissa mantissa is this part, 0 0 1. But I have to fill zeros till 23 bits. Filler zeros. Filler 0 till 23 bits. Obviously they're gonna waste space, but that's what the point is. You have to, because you are doing operation and some parts are used, so some parts remaining. What would you do about that? So 1 2 3. So I need 20 zeros. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20, and you're done. And my space is also done in board. So here we have our mantissa. Then what we would chase for is, yeah, so this is binary. So what did I say? This is E. So what do we do here is E plus bias. So for single precision we have E bias equal to 2 plus 2 plus, so bias is equal to here 127, which should be 129. So what happened here is bias is 127 in single precision. I added that and I got 129. And was it a positive number? Yes. So it was positive number, not negative number. So sign bit would be 0. Since it is positive, so it would be 0. So we would grab that 0. So what we would write is, first we write sign bit. Then what did I tell you? In the table format I have to follow. So I have to write now, exponent. Exponent is 129. But do I have to write it 129? No, this is decimal number. I have to convert it into binary. So I have to divide it by 2. 2, uh, 2 6 are 12, 2 8s are 2 8s are 9. 2, wait a second. 2 4s are 8. Wait a second, what am I doing? 1 remained. 2, 32 2s are 64. Remainder 0. 2, 16 2s are 32. So 0. Because this is divisible by 2, so we can break down those in one place. That's why we are putting them in remainder. Like a number, whatever remainder is, that would be shorter than 2, smaller than 2. So it would be 1 or 0. So I can put it, because there is no digit combination in binary beyond 2, like 1 0 0 and 1. So two numbers. So if it is beneath under that number, then it is okay for us. Okay. So when I write 2 here, 2 8s are 16. 0, 2 4s are 8. 0. Oh my god. So now I have to do is, let's go. Now continue here. 2. Oh, wait a second. I can write it here. 2 2s are 1. 2 2s are 4. 0. Remainder 2. 1s are 2. Remainder 0. 2 zeros are 0. Remainder 1. So did we do it right? And this was previous. Now this was this. Wait a second. This was this. So this was this. This is this. Yes. Let's go. And we go like this. Okay. Whoosh and whoosh. So what we have here is 129 is equal to 129 and decimal equal to 100 100 0 0 0 0 1 2 3 4 zeros and 1 1 2 3 4 and 1. So what do we have here? Exponent is 1 0 0 0 0. Where's it? 1 2 3 4 5 6 2 3 4 6. So yeah, this is actually 129 because see, this is 2 raised to 0. So obviously 1 plus 126, right? Sorry, 1 plus 128 is 129. So this is 2 raised to, this must be 2 raised to 7. And 2 raised to 7 was 128. I showed you somewhere. So 128 plus 1 is 129. Simple stuff. Also, we have to fill our place till 8 bits. So how many digits are there? 1, 2, 3, 4, 6, 7, 8. It is already 8 place. So I don't have to add zeros to fill till 8 bits to make it 8 digits. So we are done with the exponent part. Now we have to write the mantissa. So this is our huge mantissa. So let's go with that. 0 0 1 0 0 0 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. And here we go. This is our huge mantissa, and this is your IEEE format to write the stuff. Now, if you want to convert it into decimal, so you just have to do one stuff, and which is you just have to write it in -1 raised to sign, which is here 0, and multiplied by your your 1 point mantissa, because zeros don't change your number even after, like even if they're added after that, okay, and multiplied by 2 raised to e minus bias, okay. But since we are calculating here in decimals, so convert everything in decimals, okay. So I have to show you this. So this is your e, this is your m, okay. So we don't need 1 in this mantissa because obviously our formula tells it that if it is IEEE format, then 1 would be there definitely. So we don't need to write it. So we exclude writing that. Otherwise, we are just. So otherwise, we just return back to the from this stuff to this stuff, like how we got mantissa and all. So what we have to do here is also we have to convert things in decimal because these are binary stuff, and if you are doing decimal calculation, you have to convert it in decimals. So -1 raised to 0, the 0, multiplied by 1 point mantissa. 1 point mantissa, I have to convert this, like, understand this. After we shifted it, then only we got mantissa, like, till we shifted it, till we shifted a decimal place, everything was going in decimal number. Decimal and IEEE were same. After shifting the, so 1 is not the problem. After shifting the decimals, we only converted the decimals into binary. So that we have to convert. We don't have to stress about this one because it was same in decimal and IEEE, okay? And yeah, exponent is a headache. We have to convert it into, decimal and reduce it from bias, which is our 127 obviously. So what we do here is 1 point m, right? So our what do we know here? We know already the mantissa is 001 and we converted it into this. So we would obviously write this 001 into 001, I forgot, 2 raised to, so we know what this number means, this number. So this is 129. See, this is 2 raised to 7, so this is 128, and this is so you must be knowing that. Okay, I have to show you, I guess. So this is a fraction number like 1 point something. So you just have to, when you convert it into decimal, so what you do is, uh, so others are zeros. Zeros you have to ignore. You just have to take where 1 is there. So we would take 0, 0, 1 here. Then what you would do is, you have to multiply 2 raised to minus n increasingly. Okay, like 2 raised to minus 1, 2 raised to minus 2, like that. So to the left side, right side, yeah. So this would be 2 raised to minus 1 plus 2 raised to minus 2 plus 2 raised to minus 3. So what is this is, this is 0.1, this is sorry 0.0 I guess, plus 0.00, and what this is, it is 2 cubes, so it is, let's say, 0. I have to divide this by 2 cubes, so it is 1 by 8 actually. So what this is 1 here, right? So this is 1 by 8. 1 by 8, what is 1 by 8? 1 by 4 is 0.25, and if I divide 0.25 by 0.5, then it would be 0.625. I would get 0.625. So this is 0.625 definitely. So when I get 0.625, wait a second. So wait a second. Do I even need to do this 0.625 stuff? Oh yeah, I need to. Yeah, because I want decimal numbers, you know. So yeah. Okay. Let's go for it. 0. Sorry. Wait a second. Why I'm doing this again? 0.0. There is 1 here. So 1.625. Yeah, I was doing a mistake. I was doing a huge mistake because this was converted into binary. I have to convert it into decimals. So now into 2 raised to, I have to convert this exponent. So you have to multiply with increasing number, right? So multiply to increasing 2 raised to n, increasing, okay? So this was my 2 raised to minus 7, this is 2 raised to n after decimal point, to the left by the way, okay, to the left. So because this is decimal point after before stuff, and that is decimal point after stuff, after decimal point we get smaller numbers. So 2 raised to minus n means divide by 2, okay? Okay, this is divide by 2, okay? And while this is multiply by 2. That's why the difference is there. So others are 0, you can ignore that because anything you add, that won't change, and you have to add these by the way. 2 raised to 0 is 1, 1 into 1 is 1, 2 raised to 7 is 128, into 1 is 128, 128 plus 1. So this is 129, so 2 raised to 129. And you have to reduce bias. Our bias is minus 127. So in single precision. Now what we get is minus 1 raised to 0, anything raised to 0 is 1 into 1.625. Now multiplied by 2 raised to 2, because 129 minus 127 is 2, which is 4 actually, equal to is 1.625, and 2 raised to 2 is our 4. And we can see this how it's coming. So 4 5 are 20. So let's see, does our original answer come back? Because we found it like that, so it should come back, because I can already see 4 into 1 is 4, so we just getting same thing, right? Let's go, because we broke that number anyways. 4 5 are 20. We broke that number and we got this, right? 4 5 are 20, 2 carry, 4 2s are 8, 8 2 9, 8 2 10, again 0, 1 carry, 4 6 are 24, 1 is 25, 2 carry, then we have 4. Wait a second. 4 5 are 20. Okay, so 0. 2 remains. 4 2s are 8. 2. Wait a second. We are doing something wrong. 4 5 are 20. Right. Wait a second. So here I have 0 0 1. Understood? So this is 1 by 8 into 1. This is 1 by 8. So 1 by 8 is 0.625. 0.625 into 2 raised to 2. Yeah, I'm doing it correct, I guess. So what happened here right now? 4 5 are 20. 0. 2 remains. 4 to the 8 to 10. 8 to 10. 1. 4 6 are 24. 1. 25. 5. 0.5 is okay. Now, 2. 4 1 are 4. Plus 2 is 6. This is something wrong right now. Something is wrong right now, you know. Wait a second. 4 zeros are 0 plus 2 should be 2. Then we are not getting 4.5 anyways. Do I have to convert this 1 to... Oh, wait a second. Oh, wait a second. Okay. So, didn't only had to convert this. So, sorry. So, what I have to do is, I have to do 1.001. Okay, this is 1.001, which we got from here. Like, we ignored all the zeros, got 0 0, and this is 001, and this is 1 point time format. So 1 point. Our this mantissa we put it in here. 0 0 1. So now what do we do? We multiply by 2 raised to exponent minus our bias. We get 2 raised to 2. Then since this is 2 and this is binary point, so it jumps ahead because it only has 2 combinations. So it would overflow that 2 combinations and it would go 2 times ahead and it would land here. So I would have 100.1. 100.1. Now what would I do is, so now I have so this part goes away. So now I have to convert this into decimal, and to convert this into decimal I have to multiply this to 2 raised to minus n, which is wait a second. Yeah, so this is 0.1 right now. This is 1. So this is 2 raised to minus 1. 2 raised to minus 1. Okay. So this is 1 by 2. Okay. So now what we are doing is, so 1 by 2 is actually 0.5. Okay. 0.5. Okay. So wait a second. I wrote it way too huge right now. 2 raised to minus 1. Here we go. So this is 0.5. By the way, this is plus, so you don't misunderstand it. So yeah, this 1 is after decimal point. Now we have 100. Wait a second. 100. Then you have to multiply it by 2 raised to 0, then 2 raised to 1, and you have to keep increasing it. 2 raised to 2. We have to multiply, then add them, by the way. Add to 2 raised to 1, then add to 2 raised to 2. Here to multiplication. So 2 raised to 0 into 0 is 2 raised to 0. So it is 0. 2 raised to 1 into 0 is 0. Ignore the zeros. So 2 raised to 2 into 1 is 2 raised to 2 into 1 is 4. It is 4. So what do we get? 4 plus 0.5. So we have to add them. 4 plus 0.5. We get 4.5. 4.5, or we can just join them. 4.5, and here we are. We reach the conclusion. So what I'm trying to do here is you have to take screenshot and notes, okay? So I can't do it in landscape mode because in live stream it is locked orientation. So yeah, so I'm just showing you take the screenshots, okay? Here you go. So now I would zoom out and show you the full screen. Here you go. So now what I would do is I also have to solve a restoring and non-restoring division for you. So what I would do here is I would do double precision later. I guess I would solve it later maybe. What do you say? What do you guys say? Solve it in shorts, right? Let's solve it later, okay? So thanks for watching. Like, share, subscribe. See you next time. Bye. 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 Bye.